and welcome back to my channel, that is Gayatri, your Codex Mitra, and also welcome back to our statistical R programming series. And in today's video I will start with the sum of operations of a matrix in R language and which all function work with the matrix. So let's start with our video. So student, here you can see the multiple operations of a matrix. So first one is the arithmetical operation, second one is the matrix multiplication, next transpose of a matrix, inverse of a matrix, and how to access the element from the matrix. So let's see the example here. So here you can see the description as a element wise operations between the matrices of the same size. Means when we want to perform the addition, multiplication or subtraction, division, then the two matrix has to be of a same size, and these all operations perform corresponding to the each element of the both the matrix. So let's see the directly example to execute this. So here you can see I have opened the R Studio. I will start with the curly braces, and here I will create the two vectors. First one is the x1, and I will give the element as a 2, 4, 6, 8, and let's create another vector as a x2, and here I will give the elements like 2, 1, 2, 1. Now let's give this vector as a input for the matrix. So for that I will create the A matrix with the matrix function, and here I will give first as x1, and let's give the attribute as n rows, means the number of rows is equals to 2 and the number of columns is equals to 2, and let's give the value as by row is equals to true. Now let's copy this and let's change the name of the matrix as a B matrix and the input vector as a x2. Now let's perform the addition. So for that, here I will give the name as a add and A plus B. Okay, before that let's print both the matrix. So print A and let's print another matrix B, and now let's print the addition. Now select all and execute. So here you can see this is our first matrix, this is our second matrix, and this is our third matrix, means this addition. So as I told previously, this all operations happen corresponding to each element of this both matrix. So first element means the first row first column element is 2 in A matrix, and in B matrix first row and first column element is 2, so 2 plus 2 is equals to 4. Now look at the second, first row and second element is 4 in first matrix, means A matrix, and in B matrix the first row and second column element is 1, so 4 plus 1 is equals to 5. This is how the operations are performed in matrix. So let's check another operation. So for that I will change only the operator as minus, means subtraction. Now let's check, select all and execute. So here you can see element wise, means 2 minus 2 is equals to 0, 4 minus 1 is equals to 3, and 6 minus 2 is equals to 4, and 8 minus 1 is equals to 7. Now let's check the multiplication. So here you can see The 2 is multiplied by 2, the output is 4, and 4 is multiplied by 1 is equals to 4. So this is the element wise multiplication. This is not the actual matrix multiplication. So in next we will learn how to done the matrix multiplication, but this is the element multiplication. Now let's see the division. Select and execute. So 2 divided by 2 is output is 1. 2 divided by 2, and 4 divided by 1 is output is 4. 8 divided by 1 is 8 only, and here you can see 6 divided by 2, the remainder is 3. Sorry, the output is 3. So this is how the arithmetical operations works in matrix. So next one is the matrix multiplication. So it is a standard matrix multiplication, also called the dot product of two matrices. So percentage, asterisk, percentage, this is the operator used to perform the matrix multiplication of the two matrices. So matrix multiplication is the method used to combine the two matrices into a new matrix by taking the dot products of rows and columns. So it is a very important concept in mathematics, data science and machine learning. So you have to understand the number of rows in the first matrix must be equals to the number of rows in the second matrix. So let's see the example for this. Okay, let's start with the curly braces, and first I will create a vector called x1, and here I will give the element as 9, 5, 2, 1, 8, 5, 3, 1, and last one is 6. Now another vector as x2, and here I will give the element such as 3, 2, 1, 4, and 5, 3. Okay, now let's create the matrix. So first matrix name I will give it as A, and I will use the matrix function. I will pass the first vector, and number of rows means the n row is equals to 3, and the n pole is equals to 3 means number of columns. Now let's give the by row is equals to 2. Okay, now let's give for the second. Here I will give the second matrix name as B, and here I will pass the x2 vector. And first I want the 3 rows and 2 columns for the second matrix. Now let's print this. So for that, here I will use the print function, print A. Now let's print B. Okay, here I will give another variable name as mul, means the multiplication of the two matrix. So mul is equals to A. What is the multiplication symbol? So percentage, asterisk and percentage. So now select all this and run. Okay, so here you can see this is our first matrix, and this is our second matrix, and this is our last matrix, means the new matrix mul. And here you can see the matrix multiplication is means first row of a first matrix is multiplied the first column of the second matrix, then first row of the first matrix is again multiplied by the second column of the second matrix, and next the second row is multiplied by first column of the second matrix, and then the second column. Again the last third row is multiplied by first column, then the second column of the second matrix, and we have to add those multiplication and we will get this is as output. So I will create short video using the pen and paper, and I will solve this, then you will understand how it is working. So here you can see I have given here two matrix, means 3 into 3 matrix first, and the second one is 3 row and 2 columns. Now let's do the matrix multiplication. So first row is multiplied by first column of the second matrix, and again first row is multiplied by the second column of the second matrix. So let's start. So first row is multiplied by the first column, means these 3, and plus 5 is multiplied by 1, 5 into 1, plus 2 into 5. Now first column is multiplied by first row is multiplied by the second column. So 9 into 2 plus 5 into 4 plus 2 into 3. Now the second row of the first matrix and the first row of the second matrix is multiplied. So 1 into 3 plus 8 into 1, 5 into 5. So second row and second column, 1 into 2 plus 8 into 4 plus 5 into 3. Now the last, means third row first column, so 3 into 3 plus 1 into 1 plus 6 into 5. Now the third row of a first matrix and second column, so 3 into 2 plus 1 into 4 plus 6 into 3. So now let's do the multiplication. 27 plus 5 plus 10, 3 8 25. Now 9 into 2, so this is how the multiplication happens. Now let's add this. Okay, now here you can see the addition. 27 plus 5 plus 10 means 42. 3 plus 8 plus 25 means 36. 9 plus 1 plus 30, 40. 18 plus 20 plus 6 means 44. Next is 2 plus 32 plus 15, 49. 6 plus 4 plus 18, 28. So here you can see this is how the matrix multiplication happens. So here you can see these are the two matrix, 3 into 3 and 3 into 2, and first row is first multiplied by the first column, then the second column of the second matrix, and each row is multiplied by first column, then the second column. This is how we get the multiplication. This multiplication we have to add, and the addition is our last output. So lastly we get, this is 3 into 2 matrix addition. So next one is the transpose of a matrix. So the transpose functions means this T function, it converts the rows into the columns. Means a transpose of a matrix is formed by flipping the rows into columns. So it is simple words, the rows becomes columns and the columns becomes row. So let's see the example on this. Okay, here I will start with the curly braces, and here I will create one vector called x1 is equals to 1 1 and 2 comma 2. Now let's create the matrix. So max is equals to, I'll use the matrix function and I will pass these vectors x1. So number of rows is equals to 2 comma number of columns is equals to 2 and by row value is true. So now let's put the transpose of a matrix. So P is equals to transpose means P function, and here I will pass that matrix called max. Now let's first print the max, and before this here print the P matrix. Now let's execute. So here you can see the in first example means this is our original matrix. So here you can see the first two columns, first two elements are the rows, means first row contains the 1 1 value, and in our output means the transpose matrix, here you can see that row becomes the columns. Now let's create the 2 times transpose, and here I will do the M is equals to transpose of matrix means that max. So now here you can see N contains the transpose of matrix and T contains the 2 times transpose of that matrix. Now let's print the M as well. So let's see what is the output we will get. Select all and execute. So first I have print the max means our original matrix that contains the 1 1 2 2, and this contains by row values. Now the second M means the matrix transpose of a matrix. So in this case our row becomes the column. Now last one is the T matrix means the 2 times transpose. So here you can see when we will transpose first one time, then it becomes the row becomes the columns, and when we do it again means the 2 times transpose, then we will get the first means the original matrix. So here you can see again it has become as a same like a first means our original matrix. So this is how it will used to create the transpose of a matrix. So next here you can see the matrix functions, means with all function work with the matrix. So first one is the dim function, n rows n columns, next row sums and col sums, and row means and col means, and last one is apply function. So let's see one by one. So if you get the question like how do you create or how to create the matrix using the different functions, so you can use the dim function, r bind, row bind function, and a matrix function. So on these 4 functions, using these 4 functions we can create the matrix. So that I have already explained in my last video, so if you haven't watched that video, do watch. So here you can see the dim function, n row function, and n col function. So get the first one, get the dimensions, next n rows, number of rows, and n cols means the number of columns in our matrix. So let's see. So first I will start with the curly braces, and here I will use the matrix function. So A is equals to matrix of, so here I will give the 1 to 9 numbers, means here I have used the colon operator that generates the number from 1 to 9. Now next n rows is equals to, here I will give 3. So let's check the dim, or else I will give the dim A is equals to dim of small a, means our matrix name, next one is the number of columns. So here I will use the col and n col function, and here I will pass that matrix name. Now next one is the row, and rows is equal to number of rows and row, and here I will pass the matrix. Now let's print all this. So first dim A, then next the col, and last one print the number of rows. So rows variable. Now let's select and let's first print the first matrix. So print A. Now let's see. So here you can see this is our matrix, and first I have printed the dimension. So the dimension is 3 means 3 rows and 3 columns. Now the columns, so the output is 3 means we have the 3 columns, and last one is the number of rows. So here you can see we have the 3 rows, so the output is 3. So this is how you can check how many rows, how many columns, and how many dimensions you have to your matrix using these functions. So the next one is row sums and the col sums. As the name of the functions only we can understand, so it will return the sum of the elements. So first is a row wise, and the second one is col sums, means sum of the elements of your matrix column wise. So let's see in the previous example only. Okay, here I will change this as col sums, and here I will give as row sums. So select all and run. So here you can see the col sums and row sum. First I have printed the col, means the column sum. So here you can see 3 plus 2 means 5, 5 plus 1 is 6, and the second 6, 5, 11, and 4, 15. So 8 plus 9, 17, plus 7, 24, and the second one is printing the rows sum. So 4, 7, and 1, the output is 12. 8 plus 5 plus 2 is 15, and last one is 9 plus 3 plus 6 is 18. So this is how we can get the sum of the rows and the sum of the columns using the col sum function and the row sum function. So let's move to the next topic. So here you can see the row means and col means it will mean it is mean of the rows and columns, means adding how many elements are there, add that elements and divide how much elements are present, so you will get the mean of that range. So now here we have to use the row means function and col mean function. So let's check for that example. Let's change this to col means and row means. So now let's print this. Okay. Here I have given the capital A. Okay. Now let's run. So here you can see the output. So first, as I told, means we have to add each element and divide how many elements are present. So first the number of columns means of that column. So first column here you can see. So 3 plus 2 5, 5 plus 1 is 6, and here you can see 1 2 3, these are the 3 elements. So 6 has to be divided by 3. So 6 divided by 3, we will get the 2 as a output. Now here you can see the next 4 plus 5 plus 6. So 11, 4, 15, and 15 divided by 3. So we will get the 5 as output. So this is how we can we have to add, and we have to divide by how many elements are present in that range. So in row, the same, means how many elements are there, that we have to add, and we have to divide how many elements are there. So let's see the first one. So 7, 8, 9, 10, 11, 12. So 12 is divided by 3. So we will get the output as 4. So this is how the row means and col means works. So next one is the apply function. So apply function is used to apply a function across the rows and columns of the matrix. So it is a powerful tool for reducing the need of loops and making the code more efficient. So here you can see in the example, means I have created a matrix called A, and that contains the 1 to 6 elements. And in apply function, here you can see the 3 values, means that parameters has given. So first one is A, means that is the matrix name, and next one is 1. So in first example here you can see 1, and in second example here you can see the 2, means this is the margin, means the 1 stand for the rows and 2 stand for columns. And lastly here you can see the sum and mean, means this stands for the function, means which function you want to add for columns or rows, and on which matrix. So we can specify this all parameters. So first one is the matrix name, second one is means rows and columns, 1 stand for rows and 2 stands for columns, and last one is the function name. So let's see the example. Okay, let's remove this mean, and here I will create name for variable for the apply function, and apply, here I have to give first a matrix names name, and then we have to add the rows or columns. So first here I have used 1, means the rows, and I want the sum. So let's print this B. Now let's execute. So here you can see sum of the all rows. 7 plus 4 plus 1 is 12, and 8 plus 5 plus 2 is 15, and next is 9 plus 6 plus 3 is 18. So this is how we can apply the functions using the apply function. Now let's see the mean. So we can run. So here you can see the mean of these rows. So this is how you can use the all functions using the apply function, and you can specify the rows and columns using 1 and 2. So let's check the mean for the columns. So here you can see the mean of the columns. So for that we have to use the 2 to apply that function for the columns. So that wraps up our today's video on matrices, means matrix operations, and which all function work with the matrix. So I hope this video will help to understand the R language, and if you like this video, then don't forget to share and subscribe to my channel, and thank you for watching. Bye bye.